Alright, so I'm going to show you guys how to graph specific angles, both in degrees and radians. You guys have been working with degrees with bearing, but unfortunately we got to kind of flip gears a little bit, and we got to think of them in terms of angles in a circle. So now we're going to start 0 degrees on the positive x-axis. That's the biggest shift. So with bearing we would start at north, but with my unit circle or my degrees from a circle, we're going to treat the positive x-axis as my starting point. Then we're going to go counterclockwise. So we're going to go up, think of that way for positives, down for negatives. So 136 degrees, well, each quadrant is still 90. So here would be 90, 180. So we're going to go right about here. And that would be my 136. You don't have to put the 136, but definitely put your little loop so that you can tell what degree or what movement you went. Then we've got another positive. So 710 is greater than 360, so that throws some people off sometimes. So we got to think about it as going around multiple trips around the circle. So we start on my positive x, go up for positive. So one trip around is 360 degrees, but I have to go all the way to 710. 2 trips around would be 720. So I'm going to go almost all the way back around, and that's my angle. That's my 710. Make sure you have those circles to show that you went around more than one time. Otherwise, you're showing a 350-degree circle. Then the last one would be a negative. So negative 285 just means I'm going to go down from the positive x. So negative 270, I'm going to go about 15 more. That's my angle. If we switch gears a little bit, so we're going to be dealing a lot with radians. Degrees will pop up, and sometimes you guys just forget about them. Radians are going to be huge with our unit circles and trig. So the best way to do this is we still think of my positive x as my starting point. That's 0. Now it's 0 radians instead of 0 degrees. We know one complete revolution is 2 pi radians. So it's 0 or 2 pi, same thing as 0 or 360. Half of that would be 1 pi. So we've got 0, we've got 1 pi. We also know this would be pi over 2, because it would be half of my pi. This would be 3 pi over 2. But when you're doing these, especially in the beginning, you always look to your denominator. So it's changing for all of these problems, but for this one we've got a denominator of 7. That means that I'm going to make this a form of 1 pi using my same denominator. So I'm going to make it 7 pi over 7. That makes it a denominator, or I'm sorry, a reduced form of pi, but now we have it in terms of the denominator that I'm working with. If we were to split this up, half of 7 would be 3.5 pi over 7, and then this would be 10.5 pi over 7. So if we were to sketch these out, I want to go to 6 pi over 7. That's going to be somewhere between 3.5 and 7, much closer to the 7, and that would be my 6 pi over 7 radians sketched out. It's an angle, it's just a different unit than degrees. Negative 11 pi over 6, same thing. So we're going to make this 6 pi over 6 because my denominator was 6. So I'm going to make it a form of 1 pi. This would be 0 or 12 pi over 6. This would be 3 pi over 6, but since we're going backwards, I'm going to go down. This would be my 3 pi since we're thinking of it that way, but I need to go to 11 pi over 6. So that's going to get me to negative 6 pi over 6, negative 9 pi over 6, negative 11 pi over 6 is almost one complete trip around the circle. Then we've got 5 pi, a couple different tricks. We know this would be 0, this would be pi, this would be 2 pi, this would be 3 pi, this would be 4 pi. So if you look at the pattern, all of the even multiples are going to fall with my 0. All of the odd multiples are going to fall with my pi on the left side, the negative x-axis. So it's positive. So there's 2 pi. There's 4 pi, and there's 5 pi. So that angle is actually just a straight line to the left.